Dynamics and inclined planes. Consider an object at rest on a rough inclined plane. So here's our object, here's the plane. The object has a weight, and of course that acts vertically downwards. Let's say the angle of the slope here is theta. Then the angle here would be 90 minus theta, and that means that this angle here would be theta. And that means that this is the adjacent if we consider the weight to be the hypotenuse. So the component of the weight acting perpendicular to the slope is W cos theta. And the component of the weight acting parallel to the slope is W sine theta. There'll be a normal reaction force from the slope. And on a rough slope, if this thing is in position or accelerating down the slope, there would be a frictional force upwards, so parallel to the slope and opposing this component of the weight. Once we've got W cos theta and W sine theta, of course, we ignore the W because it's been replaced by those components. Since the object is at rest, the forces must be in equilibrium. I mentioned if it's accelerating down the slope, we'll come back to that shortly. So the friction would be equal to W sine theta, and the normal reaction force would be equal to W cos theta. The frictional force exactly balances the component of weight down the slope. If the force down the slope were to increase, for example, we might push it or increase the angle of the slope, the frictional force would increase to compensate. So it will always exactly balance out the W sine theta up to a point. However, there is a maximum friction in a given situation, known as limiting friction. F is equal to mu r, where mu is a constant. R is the normal reaction force, which I've actually called N in the diagram over here, but N and R are both common things that we call that reaction force. Once this is reached, any additional force down the slope will cause the object to accelerate down the slope. Under the model that we use, once the object starts to accelerate, the frictional force remains at the maximum. In other words, the friction would be equal to some constant mu multiplied by the normal reaction force once the object is in motion. Once again, this is a modeling assumption that we make to simplify the problem. In reality, in many situations, once an object starts to move, the friction is actually less than when it was stationary.